Welcome to the DIY Honda Garage channel. The title of this presentation delves into the DTC P0190-16, which signifies a low-voltage condition in the fuel rail pressure sensor circuit for the 2023 and later Honda CR-V models. This error indicates that the output voltage from the fuel rail pressure sensor is below the specified threshold, triggering the Powertrain Control Module, or PCM, to recognize it as an abnormal condition. Correctly diagnosing this issue is crucial, as it can lead to engine performance problems, including poor fuel economy or rough idling. The subsequent slides will follow a structured diagnostic approach to address this error code, focusing on potential causes, symptoms, and a step-by-step troubleshooting guide. Each troubleshooting step will clarify diagnostic methods and potential components that may require inspection or replacement. Understanding the components involved, particularly their roles and locations within the vehicle, will help technicians effectively resolve the issue. Let's proceed to comprehensively explore the details of the error code and the subsequent troubleshooting steps. DTC P0190-16 refers to a low-voltage reading from the fuel rail pressure sensor, which plays a critical role in the fuel injection system of the Honda CR-V. The fuel rail pressure sensor measures the pressure in the fuel rail and sends corresponding voltage signals to the PCM, which uses this data to optimize engine performance and fuel delivery. Located integrated with the fuel rail, this sensor's output voltage should typically read around 5 volts under normal operating conditions. When the voltage drops below specified levels, the PCM detects this anomaly and records the DTC. The current readings from this sensor can indicate the operational status of the engine's fuel systems and the efficiency of the fuel delivery, making it an essential component for maintaining optimal vehicle performance. If the fuel rail pressure sensor is malfunctioning, it could severely impact engine performance, leading to drivability issues that may warrant immediate attention. There are several potential causes for DTC P0190-16. Firstly, a malfunctioning fuel rail pressure sensor is one of the primary culprits. If the sensor itself is defective, it won't be able to provide the proper voltage readings to the PCM, leading to erroneous data interpretation and suboptimal engine function. Secondly, issues concerning the related wiring or connections can also contribute to this DTC. Damaged wiring or poor connections may result in voltage drops or interruptions in the signal transmission, thus causing the sensor to appear faulty. Lastly, while less common, a failure within the PCM could also lead to this error code. As the central component responsible for processing signals from various sensors, a malfunctioning PCM may misinterpret valid sensor inputs or fail to process them accurately, resulting in low voltage detection. Each of these causes necessitates thorough investigation through systematic troubleshooting methods. When DTC P0190-16 is present, several symptoms may become apparent that indicate an issue within the fuel delivery system. One of the most noticeable symptoms is engine misfires, which can lead to a lack of power and inefficient engine performance. This misfiring occurs because the engine is not receiving the appropriate amount of fuel for combustion due to faulty readings from the fuel rail pressure sensor. Additionally, drivers may experience poor fuel economy, as the engine may compensate inadequately for the erroneous pressure readings, leading to excessive fuel consumption. Another common symptom is rough idling. The engine may struggle to maintain a stable idle speed, resulting in vibrations or a feeling of choppiness during stops. These symptoms underline the importance of timely diagnosis and repair. as they can significantly affect overall vehicle performance and driver experience. The first troubleshooting step for DTC P0190-16 involves turning the vehicle ignition to the on position and waiting for approximately 2 seconds. This initial step is crucial as it allows the vehicle's systems to power up, including the onboard diagnostic tools. Following this, the Honda Diagnostic System, HDS, should be utilized to check the value of fuel pressure converted from PF sensor voltage. If this value falls below 0.31 volts, it confirms the recurrence of the failure, indicating a continued low voltage condition from the fuel rail pressure sensor. This data is vital because it not only reinforces the presence of the DTC, but also helps pinpoint whether the sensor is functioning correctly or if the issue lies elsewhere in the fuel system. Proper execution of this step sets the stage for subsequent troubleshooting measures. The next troubleshooting step requires the technician to disconnect the fuel rail pressure sensor connector, which is a 3-pin connector, 3P. After disconnecting this connector, it is essential to perform voltage output inspection under IG mode. The normal output voltage should read approximately 5.0 volts. This reading is critical as it indicates that the sensor is indeed receiving proper power. If the sensor outputs this normal voltage level, it suggests that the sensor itself is operating correctly. Conversely, if the output voltage is less than expected, this indicates a malfunction within the fuel rail pressure sensor, warranting further inspection or replacement of the component. Thus, this step is essential in identifying whether the sensor itself is the root cause of the issue, or if other components may be contributing to the low voltage condition. In this step, the focus shifts to the VCC1 circuit associated with the fuel rail pressure sensor. Before proceeding, it is crucial to disconnect both the fuel rail pressure sensor connector and the PCM connector B101P to facilitate the inspection of circuit integrity. The technician must then conduct a check to determine whether there is continuity in the VCC1 wiring by performing a resistance test. Normal readings should indicate resistance levels of less than 1 ohm. This means that the wiring is intact and functioning correctly, without any breaks or shorts that could affect voltage supply to the sensor. Discovering that the resistance exceeds this threshold suggests a problem within the circuit itself, which may require further investigation into wiring conditions, connections, and any potential shorts present in the system. Therefore, maintaining low resistance levels is critical for ensuring the proper operation of the entire fuel delivery system. The next step is focused on inspecting the PF circuit for any potential shorts to ground. Again, both the fuel rail pressure sensor connector and the PCM connector B must remain disconnected during this testing process to ensure accuracy. It is crucial to perform a resistance check and confirm that the PF circuit does not have any shorts, with readings indicating a resistance level greater than 1 megaohm. This indicates that the circuit is clear from any shorts and is capable of carrying the signals correctly to the PCM. A reading below this threshold could signify significant issues such as improper grounding or damage along the PF wiring harness that may lead to erroneous voltage signals being relayed back to the PCM. This step is vital to ensure that the signals from the fuel rail pressure sensor are not getting compromised, as doing so could have broader implications on engine performance. The fifth and final troubleshooting step involves evaluating the performance of the powertrain control module, PCM. If all previous inspection steps related to the fuel rail pressure sensor and associated circuits indicate normal conditions, the next logical cause to investigate is the PCM itself. In the automotive context, the PCM serves as the brain of the engine management system, processing inputs from various sensors to adjust engine functions appropriately. Should the PCM fail to interpret the data correctly or exhibit abnormal behavior, it could mistakenly trigger DTC P0190-16, despite the sensor and circuitry being operational. Verifying that other inspection components function correctly will help to strongly suggest that the PCM is the root cause. In such cases where the PCM is at fault, it would require either reprogramming, testing, or in some instances, replacement to ensure accurate fuel pressure management within the engine, restoring normal vehicle operation. After completing all necessary repairs associated with DTC P0190-16, it is critical to perform a final verification of all repairs made. Confirming that each item is addressed according to the previous diagnostic steps ensures that nothing is overlooked. Subsequent to this, retesting the affected fuel delivery system and checking the outputs from the fuel rail pressure sensor with the Honda Diagnostic System, HDS, again is essential to ensure that everything is functioning correctly. Following proper repairs and adjustments, it is advisable to clear the DTC using the HDS and then drive the vehicle under various conditions. This drive test allows the PCM to reevaluate the sensor inputs and confirm that the issue no longer persists. Affected performance areas, such as engine responsiveness and fuel efficiency, should also be monitored to ascertain full operational restoration. This final verification step is crucial in a professional repair environment, assuring both the technician and the vehicle owner that the issue has been completely resolved. Preventive maintenance is paramount in ensuring the durability and reliability of the fuel rail pressure sensor system in the Honda CR-V. Regular inspections should be conducted to assess the integrity of the fuel rail pressure sensor, including checking for signs of damage or wear that could lead to malfunction. Additionally, it's vital to routinely check the condition of the wiring associated with the fuel rail pressure sensor to prevent issues like shorts or corrosion that can impact performance. Ensuring that electrical connections are clean and secure will provide a more stable operational environment for the sensor and improve its reliability. Finally, maintaining optimal functionality of the PCM through periodic updates and diagnostics not only enhances the effectiveness of the vehicle's engine management system, but also minimizes the occurrence of error codes that could detract from vehicle performance. Implementing these practices will help mitigate potential issues before they escalate into major repairs. In conclusion, diagnosing and addressing DTC P0190-16 requires a systematic approach rooted in thorough troubleshooting steps. Each step highlights the importance of examining various components, from the fuel rail pressure sensor to the associated circuits, and ultimately the PCM itself. Proper understanding of the roles and functions of each of these parts plays a crucial role in effective diagnosis and repair. As demonstrated, regular maintenance practices are vital in preventing recurring issues and ensuring that the fuel delivery system operates efficiently. Moreover, prompt and accurate repairs are essential in maintaining vehicle performance and reliability, thereby enhancing the overall driving experience. By adhering to these guidelines and being proactive in vehicle care, owners of the Honda CR-V can enjoy longer-lasting performance without unexpected downtimes. Please like and subscribe to the channel. See you next time!